burnt part described is likely a surge suppressor or transient voltage suppressor, also known as a TVS. It is a type of device that protects electronic circuits from sudden voltage spikes or transients. Type B surge suppressors are designed to handle lower energy surges than Type A or Type C suppressors. They are commonly used in applications where the surge current is relatively low, such as in appliances and consumer electronics. You can find suitable replacement surge suppressors from various electronics suppliers, including Digi-Key Electronics, Mouser Electronics, and Newark Electronics. To ensure compatibility, it is important to determine the following specifications of the original surge suppressor. Firstly, the voltage rating. This should be 115 volts alternating current, which is the input voltage. Secondly, the current rating. This should be sufficient to handle the surge current. Thirdly, the terminal configuration. Make sure the replacement suppressor has the same number and arrangement of terminals as the original. Once a suitable replacement suppressor has been obtained, it can be installed by 1. Carefully desoldering the burned suppressor from the circuit board. 2. Soldering the new suppressor into place, ensuring proper orientation and terminal connections. 3. Testing the power supply to ensure it is functioning correctly. It is critical to select a surge suppressor with appropriate voltage and current ratings to protect the power supply from future voltage spikes. Consider the surge current that the compressor motor might generate and select a suppressor with a sufficient rating to handle it. Ensuring the replacement has the same number and arrangement of terminals as the original is also very important. This will simplify the installation process and avoid any wiring errors. Always double-check the polarity and connections before powering up the power supply. Incorrect wiring can damage the new surge suppressor or other components in the circuit. If unsure about any aspect of the replacement process, it is always best to consult with a qualified electrician or electronics technician. Working with electrical components can be dangerous, and it is important to take necessary precautions to avoid electrical shock or other injuries. Before starting any work on the power supply, disconnect it from the main power source to prevent any accidental electrocution. Use appropriate tools and equipment for desoldering and soldering, and follow proper safety procedures. After installing the new surge suppressor, test the power supply thoroughly to ensure that it is functioning correctly. Check the output voltage and current to make sure they are within the specified ranges. Monitor the power supply for any signs of overheating or other abnormalities. If any issues are detected, troubleshoot the circuit to identify the root cause and take corrective action. Regular maintenance and inspection of the power supply can help prevent future failures. Check for loose connections, damaged components, and signs of corrosion. Clean the power supply regularly to remove dust and debris that can cause overheating. By following these steps, you can effectively identify and replace a surge suppressor in a power supply, ensuring its continued operation and protecting it from future voltage spikes. When selecting a replacement surge suppressor, pay close attention to the voltage rating. The surge suppressor's voltage rating should match the voltage of the circuit it's protecting. In this case, the input voltage to the compressor motor is 115 volts alternating current, so the surge suppressor should also be rated for 115 volts alternating current. Using a surge suppressor with a lower voltage rating could cause it to fail prematurely, while using one with a high voltage rating may not provide adequate protection. The surge suppressor's current rating indicates the maximum amount of current it can handle during a surge event. The current rating should be sufficient to handle the surge current generated by the compressor motor. To determine the appropriate current rating, it's important to consider the motor's starting current, which can be several times higher than its normal operating current. Consult the motor specifications or the power supply's documentation to find the starting current. When choosing a replacement surge suppressor, it's essential to match the terminal configuration of the original component. The terminal configuration refers to the number and arrangement of the terminals or leads that connect the surge suppressor to the circuit board. Using a surge suppressor with a different terminal configuration could make it difficult or impossible to install it correctly. Before desoldering the burned surge suppressor, take a picture or make a sketch of its orientation and terminal connections. This will help ensure that the new surge suppressor is installed correctly. Use a desoldering iron or desoldering pump to remove the old surge suppressor from the circuit board. Be careful not to damage the circuit board traces or pads during the desoldering process. Clean the circuit board pads with isopropyl alcohol and a cotton swab to remove any residual solder. When soldering the new surge suppressor into place, ensure that the terminals are properly aligned with the circuit board pads. Use a soldering iron with a fine tip and apply heat to the terminal and pad simultaneously. Feed solder into the joint until it forms a smooth, shiny connection. Avoid using too much solder, as this can create a short circuit. After soldering the new surge suppressor, inspect the soldered joints carefully to ensure that they are free of defect. Look for cold solder joints, which appear dull or grainy, and resolder them if necessary. Use a multimeter to check the continuity of the circuit and ensure that there are no short circuits. After installing the new surge suppressor, test the power supply to ensure that it is functioning correctly. Connect the power supply to a power source and check the output voltage and current. If the power supply is not working correctly, double-check the installation of the surge suppressor and look for any other damaged components. In some cases, the original surge suppressor may have failed due to an underlying problem in the power supply. If this is the case, it's important to identify and fix the underlying problem before installing a new surge suppressor. Replacing a surge suppressor in a power supply can be a relatively simple repair, but it's important to take the necessary precautions and follow proper procedures to ensure that the repair is done safely and correctly. If unsure about any aspect of the repair, it's always best to consult with a qualified electrician or electronics technician. Additionally, understanding the function of a surge suppressor within the power supply circuit can be valuable. A surge suppressor, as the name implies, protects the circuitry from voltage surges or spikes that can occur due to various reasons such as lightning strikes, power grid switching, or even internal equipment malfunctions. These surges can be significantly higher than the normal operating voltage and can damage sensitive electronic components. The surge suppressor typically works by diverting the excess voltage away from the protected components. One common type of surge suppressor is a metal oxide varistor, also known as an MOV. An MOV is a voltage-dependent resistor that has a higher resistance at normal operating voltages. However, when a voltage surge occurs, the MOV resistance drops dramatically, allowing the surge current to flow through it and away from the protected components. The MOV can absorb a certain amount of energy from the surge, but it can also be damaged or destroyed if the surge is too large. Another type of surge suppressor is a transient voltage suppression diode, also known as a TVS diode. A TVS diode is a semiconductor device that is designed to protect circuits from voltage transients. When the voltage across the TVS diode exceeds its breakdown voltage, it begins to conduct current, clamping the voltage and diverting the surge current away from the protected components. TVS diodes are typically faster and more reliable than MOV, but they can also be more expensive. The location of the surge suppressor within the power supply circuit is also important. Surge suppressors are typically placed at the input of the power supply to protect all of the downstream components. They may also be placed at other strategic locations within the circuit to protect specific components that are particularly sensitive to voltage surges. When selecting a replacement surge suppressor, it is also important to consider the energy rating of the device. The energy rating indicates the amount of energy that the surge suppressor can absorb without being damaged. The energy rating should be sufficient to handle the expected surge energy in the application. Finally, it is important to note that surge suppressors are not a foolproof protection device. They can be damaged or destroyed by large voltage surges. Therefore, it is important to use surge suppressors in conjunction with other protection measures such as proper grounding and shielding. Proper grounding helps to ensure that voltage surges are safely diverted to ground, while shielding helps to prevent voltage surges from entering the power supply in the first place. The documentation referenced online for the part that was called the chatter protector might have been a misnomer. It is more accurately described as a surge suppressor. The term chatter protector is not a standard term used in the electronics industry. It is possible that the term was used by the manufacturer of the marine or RV refrigerator to describe a surge suppressor that is specifically designed to protect the compressor motor from voltage transients. Compressor motors can generate voltage transients when they start and stop. These transients can be particularly damaging to electronic components, such as the power supply. A surge suppressor that is specifically designed to protect the compressor motor from these transients may be referred to as a chatter protector. To confirm the function of the component, it is recommended to consult the power supply's schematic diagram. The schematic diagram will show the location of the component within the circuit and its connections to other components. This information can be used to determine the component's function. It is also possible to contact the manufacturer of the marine or RV refrigerator and ask for more information about the component. The manufacturer may be able to provide a datasheet or other documentation that describes the component's function and specifications. We remember that it is very important to take necessary safety precautions when working with electrical components. Always disconnect the power supply from the main power source before starting any work. Use appropriate tools and equipment, and follow proper safety procedures. If unsure about any aspect of the repair, it is always best to consult with a qualified electrician or electronics technician. When you go to purchase the replacement, you may also want to consider other factors such as the operating temperature range of the surge suppressor. This is especially important if the power supply is located in an environment that is subject to extreme temperatures. The surge suppressor should be able to operate reliably within the expected temperature range. You may also want to consider the surge suppressor's response time. The response time is the time it takes for the surge suppressor to start clamping the voltage after a surge occurs. A faster response time is generally better as it provides better protection for the downstream components. Finally, you may want to consider the surge suppressor's clamping voltage. The clamping voltage is the voltage at which the surge suppressor starts to conduct current and clamp the voltage. The clamping voltage should be low enough to protect the downstream components, but high enough to avoid nuisance tripping. In summary, replacing a surge suppressor in a power supply requires careful attention to detail and a thorough understanding of the component's function and specifications. By following the steps outlined above, you can effectively repair your power supply and protect it from future voltage surges. Always prioritize safety and consult with a qualified professional if you have any doubts or concerns. The key considerations for selecting a replacement surge suppressor are voltage rating, current rating, terminal configuration, energy rating, operating temperature range, response time, and clamping voltage. Make sure to match these specifications to the original surge suppressor or to the requirements of the power supply circuit. Also, keep in mind the application for which the power supply is being used. Marine and RV applications can be subject to harsh environmental conditions such as moisture, vibration, and extreme temperatures. Choose a surge suppressor that is specifically designed to withstand these conditions. Look for surge suppressors that are rated for marine or RV use. These surge suppressors are typically more robust and resistant to corrosion. Finally, remember that surge protection is an important part of overall electrical safety. Always use surge suppressors to protect your electronic equipment from voltage surges. Surge suppressors are relatively inexpensive and can save you from costly repairs or replacements. Always handle electrical components with care and follow proper safety procedures. If you are not comfortable working with electrical components, consult with a qualified electrician or electronics technician. Consider the physical size and mounting requirements of the replacement surge suppressor. Make sure that the replacement surge suppressor will fit within the available space in the power supply and that it can be securely mounted. The shape and size of the replacement should be similar to the original to facilitate easy installation. Before replacing the surge suppressor, inspect the surrounding components for any signs of damage. If any other components are damaged, they should also be replaced. Damaged components can cause the new surge suppressor to fail prematurely.